Right, to find the maximum or minimum value of a function, we want to write our terms in one variable equations. All right? Next, we want to find the first derivative and set it equal to 0. That will give us our critical points. Okay? And what happens at critical points? That's where our maximums and minimums occur. And lastly, if there are any endpoints, we want to check those if necessary. All right? So, let's take a look at our first example here. Let's find two numbers whose sum is 20. Well, that means if I add two numbers, that should give me 20. And whose product is as large as possible. That's where maximization is occurring. That's what we're going to take a derivative of. X times y equals some number that we're trying to maximize. I know it's a constant. It's some constant c. All right? Well, since we're going to take a derivative of this, let's try and write that with one variable. So I'm going to take my sum equation here and get that in terms of one of my variables. In this case, I'll put it in terms of y. Now, wherever there is a y, I can put in 20 minus x. Let's say x times 20 minus x equals still some number. We haven't taken the derivative of this yet, and that's fine. Let's make it even easier. I'm going to distribute this x into here. So I've got 20x minus x squared equals some number. Now I'm ready to take the derivative of that. The derivative of this will be 20 minus 2x equals, since this is a constant, the derivative of any constant is 0. Alright? I want to solve that so I know what critical point, what value of x will a critical point occur at. Well, if I add 2x to both sides, I get 20 equals 2x. Therefore, x equals 0. That's where one of my critical points happens. So, in the graph, in the number line of my derivative, okay, at 10, that's where I get a slope of 0. Let's not forget that my derivative is 20 minus 2x. All right, well, let's try the number 9. Okay? 20 minus 2 times 9, that's 20 minus 18, that's a positive 2. That means it will be positive left of my critical point, the slope, because the slope is my derivative. Let's try the number 11. Okay? 20 minus 2 times 11, well, that's 20 minus 22. That gives me a negative number. So what does that mean? My function will have a positive slope going up to 10, have a slope of 0 at 10, and then slope down after 10, which means this is a max point. Which means when x is when x is 10, what's my y? Well, I can use this right here. Y is 20 minus x. If x is 10, my y is also 10. Those are two numbers that when they add to 20, that will maximize the product between them. The next example we have here says, you have 40 feet of fence to enclose a rectangular garden along the side of a barn. What is the maximum area that you can enclose? Don't start assuming that you have 2 lengths and 2 widths of fence. All right, let me explain to you in a picture. If here's my barn. This is my barn right here. All right, I have a garden, a rectangular garden. Here it is right here. So here's my garden. I don't need to put fence where the barn is. My fence is only going to go around the 3 sides because the barn encloses it. So if this is an x value, this is an x value, this is a y value. I have 40 feet of fence here. That means 2 of my x's plus my y is going to give me 40. All right? And they want to know, they want to maximize area. Well, what's the area of a rectangle? Length times width. In this case, x times y. And it is going to maximize to some number that I'm trying to figure out This is what I'm going to take the derivative of, because that's what I'm trying to maximize. I want to write that in terms of one variable. So again, I will solve the other equation in terms of one of my variables. Wherever there's a y, I can plug in 40 minus 2x. All right? So some number is going to give me x times 40 minus 2x. And if I distribute that x, I get 40x minus 2x squared. Now I can take the derivative of it, maximize it, find out that critical point, which we're hoping will be a maximum point, and get my dimensions. Okay? So the derivative of any constant is 0. This is 40 minus 4x. All right? What does that equal to 0 and solve? Well, in this case, my x would be 10. Because 4 times 10 is 40, and 40 minus 40 is 0. This is my critical point. Let's make sure that that is a maximum and not a minimum. If this is 10, this is where my zero slope occurs. This is my derivative values, okay? My derivative was what? 40 minus 4x. So let's try the number 9 again. Actually, I can try the number 0 if I want. I can pick any number to the left of 10. And for the sake of ease, why not? Let's try 0. 40 minus 4 times 0, well, that's still 40. That's a positive number. This will slope up to 10. Let's try 11. I can pick any number to the right. I could have picked 20. I could have picked 100 if I wanted to. So we have 40 minus 4 times 11, which is 40 minus 44, which is negative 4. That is negative. It slopes down, which means this is indeed a max point. So the max points x equals 10. And what's my y? Well, I just throw a 10 in for x in one of my original equations. 40 minus 2 times 10 is 20. My y is 20. Which means this side would be 20, this side would be 10, this side would be 10. That adds to 40, and that area would be 200. That is our max area. Square units, or is it feet? Square feet. Which means it should be 10 feet, and it should be 20 feet. Good to go. What dimensions for a 1 liter cylindrical can will use the least amount of material? Now, when I'm thinking the material for this can, I'm thinking surface area. And in case you forgot, surface area of a cylinder is 2 pi r squared plus 2 pi r h. So, if I want to use the least amount of material, okay, some number to represent the surface of this material is going to equal 2 pi r squared plus 2 pi r h. That's what I'm taking the derivative of, and that is what I'm going to try and make one variable. I currently have 2 variables. I have my r for radius and my h for height. So they give us this little note right here. And since area would be units squared, volume is units cubed. So volume is pi r squared times height. All right? And they tell us that the volume of this is a 1 liter cylinder. Well, they say no, 1 liter is 1,000 centimeters cubed. So I'm going to make my volume, instead of 1 liter, 1,000 centimeters cubed. All right? I will not write the label on until after we're done doing the math. That equals pi r squared h. Well, if I want to get the h alone, I'll just divide by pi r squared. Divide it by pi r squared. This is what's equal to h. And that's what's going to go into my h. So let's start doing some more calc. 2 pi r squared plus 2 pi r times h, which we now know is 1,000 over pi r squared. Now right away, this pi can cancel with this pi, this r can cancel with one of these. And if I multiply them together, I have 2 pi r squared plus 2 times 1,000 is 2,000 over r. All right? And it's equal to some number. Let's take the derivative. The derivative of a constant is 0. The derivative of 2 pi r squared, remember, 2 is a constant and so is pi. So when I bring this out front to multiply, 2 times 2 pi is 4 pi times r, because I reduced my exponent from 2 to 1. Plus, all right, I can use low d high minus high d low, draw a line and square below, or I can rewrite this as 2,000 times r to the negative 1. But remember, that's positive 1. If I bring that r up, I need to negate my exponent. And I can just use the exponent rule here. Bring my exponent out front. Negative 1 times 2,000 is negative 2,000. And I reduce my exponent by 1. So I go from negative 1 minus 1 to negative 2. And if I want to rewrite that all nice and pretty, then it's negative 2,000 over r squared. I'll flip that. That was over 1. I bring that down to make it positive. So now, I can just say minus 2,000 over r squared. I need to solve this for r. That's my derivative. Well, I'd like to get rid of any denominators, so I'm going to multiply everything by r squared. Zero times anything is 0. This will become 4 pi r cubed, and these cancel, minus 2,000. All right? Not so bad. Not so bad. I'm going to add 2,000 to both sides. I've got 2,000 equals 4 pi r cubed. I'll divide both sides by 4 pi. So I now have 500 over pi equals r cubed. And I get 500 because 4 was in the 2,000. Oops, 500 times, not 5,000. Got 0 happy there for a second. Now, I need to take the cubed root of this to solve for r. And I will definitely use the calculator. So my radius is going to be approximately, turn this on. I'll go math. I'm going to go to the cubed root. And in there, I'm going to put the fraction 500 over, and I am going to put pi there. That is approximately 5.419. That's centimeters, right? Man, I gotta learn how to write. Now, they want to know the dimensions. So not only do we have the radius, we need the height. What was our height? Height equals this. So height is going to approximately equal 1,000 over pi times our radius squared. And again, I'm going to use a calculator. I'm going to put this in for my radius here. So, I will say height is equal to 1,000 over pi times, and I'm going to put this number, oh, you stinky, stinky person. Let me do it this way. I'm going to store this as my x, instead of having to read something. So anytime I hit x, I have my radius value. So now, let's go ahead and do this. 1,000 over pi times my radius, which is in the x, squared. And I get 10.838. That's my height in centimeters. And this is my radius in centimeters. There you go. And if you wanted to get technical, they wanted a minimum, correct? On our number line, for our derivative, right? R was 5.419, okay? Our derivative was this equation right here. No, it was this one right here, I'm sorry. This is our derivative. Before we multiplied everything times r squared, we had 4 pi r minus 2,000 over r squared. Minus 2,000 over r squared. So if I pick the number 1, that would be negative. That would be 4 pi minus 2,000. That is definitely a negative number. 4 pi is 12 point something, 14 somewhere number. That's a negative number. And if I picked the number 100, I don't know, I'm getting zero happy. If I pick 100, well, if I put 100 in here, it's 4 pi times 100 minus 2,000 over 100 squared. That is definitely positive. That's 400 pi, which is 12,000 something, minus, oh my god, 2,000 over 10000. I mean, that's a fraction. That is 2/10, 1/5. 400 minus 1/5 is definitely a positive number. This goes down, that goes up. This is a minimum point. And that's what you want, to use the minimum amount of material. Let's talk money. Suppose that R of X represents our revenue, and C of X represents our cost to build something. If we want to know how to maximize that, I take how much I can make and subtract how much it costs me to make them. And that gives me some sort of number that represents my profit. If I want to maximize it, we're talking derivatives. Derivative of my revenue minus the derivative of my cost should equal, well, the derivative of a constant is 0. If I really want to get fancy here, I can keep this equation the same by adding the derivative of C to both sides. So I get the derivative of my revenue should equal the derivative of my cost. And that's how we're going to maximize profit. So this is what I'm going to do to figure out that max point. Okay? The derivative of my revenue is just 9. The derivative of my cost is going to be 3x squared minus 12x plus 15. Well, set them equal to 0 and let's solve. All right, well, let's subtract 9 from both sides. And I've got 3x squared minus 12x plus 6 equals 0. All right, I'll factor out a 3. And I've got x squared minus 4x plus 2. Interesting. Equals 0. Now, there are 2 ways you can do this. You can use a quadratic equation, or you can put this in the calculator and find your x-intercepts. All right? Let's use the quadratic equation just for now. Okay? You know what? Let's make it easy. I assume you guys all know how to use a quadratic equation. Let's graph this. We can even graph this one right here. All right? It doesn't matter, even before I factor. So, we'll open up this calculator, open up our second calculator, and the equation that I'm going to put in there is out 3 y equals, I'm going to put in there 3x squared minus 12x plus 6. And when I graph that, there are two spots where it crosses the x-axis. And I'm going to use my zero function to find those out. Okay, I'm to the left of my first one, and to the right, and make my bow tie, enter. 0.585. Okay, so x is going to be approximately 0.585. Now, these are numbers of units in thousands, so that leaves approximately 585 units. Now, let's find my second x-intercept, okay? The 0 of my second one. Okay, I've got to be to the left of it, which I am. And I'm going to be to the right of it. There I go. Hit enter. There it is, and it's 3.414. Okay, so my other one is approximately 3.414. All right, approximately. So, these are units in thousands. So how am I going to max? It's going to be approximately 585 if I multiply it times 1,000, or approximately 3,414 units. Which one will maximize profit? Well, let's take a look at the graph with both our equations in it. The first one, 9x, is our revenue. The second one is our cost. If I look at this graph right here, and I'll bring this out here. This is, in green, the money we want to make. Okay, that's our revenue. Okay? The cost of the money we pay is this curved line here. So there are 2 points where these lines are furthest apart. One at 3.414. No, 1, 2, I'm sorry, that's right here. And the other point is 0.585. Now, this is a gap. It's definitely a far gap right there. And this is a gap here. We want the gap where our revenue is higher than our cost. So we want this gap right here. This gap has our costs more than our revenue. So this is actually a maximum loss of money here. This represents a maximum profit. So we definitely want that value right there. Now when it comes to minimizing the cost that we spend, all right, average costs, okay, if this is my equation for costs, all right, and it's x cubed minus 6x squared plus 15x, how do I find out the average? Well, I divide that per unit, right? I divide it just by x. If I'm taking some value x and I'm cubing it, subtracting 6x squared plus 15x, we don't want to take that per value of x. I just divide it by x. So, really, this is c of x, that's my cost. This is per units, and divide it by my per unit, and that will give me the average cost. So, if I actually work that out, that'll give me x squared minus 6x plus 15. All right? This is the average cost per unit x. Okay? Because I take my cost and I divide it per unit x, and that's what I get. All right? Now, if I want to figure out, so if this is the average cost, well, I want to minimize my spending. Right? I want to minimize costs. Well, to minimize or maximize costs, that's the derivative, right? C prime. And we know that the derivative of cost is 3x squared minus 12x plus 15. That is just the derivative of this. Okay? So I need to figure out where my min or max is equal to my average cost. Because I will find either the maximum average cost to me or the minimum average cost to me. And I need to set those equal. So, I have 3x squared minus 12x plus 15 equals x squared minus 6x plus 15. All right, I'm going to bring everything over to one side. Minus x squared, minus x squared. plus 16x plus 16x minus 15 minus 15. And when everything is said and done, I've got 2x squared plus 4x, and these cancel out, equals 0. Actually, it should be a 6 and a 16. So, negative 12x plus 6 is minus 6x. Alright? Now that's actually an easy one to factor and solve. That's an easy one to factor and solve. And I pull out a 2x, and I have x minus 3 equals 0. So when I T-bone that, my x is going to be 0, my x is going to be 3, and these are thousands of units. Okay? We cannot minimize or maximize anything if we don't make any units. So this is the number of units per production, that will minimize cost for us. Fabricating a box, last and certainly not least. An open top box is to be made by cutting congruent squares out of side length x in the corners of a 20 by 25 inch sheet. This is the square that you are cutting out. And from each corner, you are cutting out this square right here, okay? And you're going to bend up the sides. How large should the squares be to make the box hold as much as possible? What's the resulting maximum volume? Alright? Well, if we fold up our box, this is what we get, right? This side is a length 20, but we take out an x and an x. So that side is going to be 20 minus 2 x's. Same thing for the width. You have 25 and you were cutting out 2 x's, so minus 2x. But the height, when I fold this up, is going to be a height of x. It's this height right here that gets folded up, okay? And volume, well, that's just length times width times height. Alright? And to save you guys a bunch of time, what I'm going to do is FOIL that out for you. If I FOIL this all out, I will get volume is 4x cubed minus 90x squared plus 500x. Now, if I want to maximize this, okay, derivative, I set equal to 0 because that's going to be the critical point where either a maximum or minimum occurs. Alright, so the volume, which is some number, will turn to 0 when I take the derivative of it. I've got 12x squared minus 180x plus 500. Woo! Let's find the two values that occurs on. Without factoring, we'll use our calculator, all right? So I'm going to go back to y equals. Turn this on. Y equals. I'm going to clear out our profit equations. So put 12x squared minus 180x plus 500. Now, I will go to my window. I will make it 0 to 10. Let's make it 0 to 12. And I really don't care about my y, so just go to 15, I guess, if I want, and I'll graph it. All right, and actually, why don't I look a little bit below the y's? So I can see, there you go, it crosses, and it crosses. So, I need to find those 2 points where they cross. Those are my zeros. And I'm going to do the bow tie. Alright? So I've got to be, there it is, left, boom. Right, that makes a bow tie, hit enter. One of my answers is 3.681. So x is approximately 3.681. What's my other intercept? Well, I'm going to do my 0 again, and this time, keep on going, here I come, coming back up, there we go. Almost back up, coming up at a fast pace. Left, right, I made a bow tie, hit enter, 11.318, let's call it. Now these are in inches, I believe, right? centimeters? Let's see. Inches. There you go. Now, but which one is it? Which one is it? How come it is not 11? Because this side is 20. If I cut 11, if this x is 11 and I cut 11 inches here, and I cut 11 inches here, that's taking 22 inches away from a side that's only 20 to begin with. I don't have that much material to cut out. So, this is the approximate value I will use to maximize my volume. That's the length, the value of x, the side of the square I need to cut. All right, that's what that dimension for that x for that side of that square that we cut out needs to be. They want to know what the maximum volume is now that I can have in that box. So volume, this is my equation of volume. So I'm just going to put a 3.681 in here, and here, and then here, multiply them all together. And what I'm going to do is use my calculator. And I'm going to say 3.681 times 20 minus 2 times 3.681. Okay? Times 25 minus 2 times 3.681. Time check. That'll be 820. All right? 820.528 inches cubed. All right? So my volume is going to be 820.528 inches cubed. And that's the volume of our rectangular prism.